All right. Good morning.
Good morning.
All right. So we're getting ready for our second test. We finish up the logic chapter. So today is our review day. So anything you want to look at?
Well, if we could please um, do a short review of the things I had missed the other day, I'd appreciate it.
Well, I thought that's what I had done yesterday because I didn't quite get a picture of what you had missed. I thought it was just the truth tables because I thought you were here for the initial, what a statement is and that type of thing.
Well, I'm gonna go over the other recordings just to make sure.
Right.
But I just have a lot going on right now.
Right.
But I'm trying to keep up. You know.
All right. Well, like I said, if I got an idea, right now I think I wanted to see if anybody's got any specific questions, and if we do that, because yesterday, my intention was to give a short review of things, but I mainly concentrated on the truth tables because that's the core of it.
Right.
The truth tables is the heart of everything. It's 3/4 of that chapter.
Right.
Because
So my thing,
go ahead.
I was just gonna say my thing. The truth tables, I feel like I have it. It's the biconditional statements. I don't know. I get tricked up. 1 minute I'm on a roll, and then one comes, and it just makes me doubt everything.
You want to give me an example of one?
I believe. Let me go. I don't know if I could share my screen. Let me see.
If I stop sharing mine, you should be able to do it.
Okay, but just give me a minute. I don't want to hold everybody up. I'm gonna try to find it.
All right. What about anybody else? They've got something specific? Like I said, if you got a particular problem, it really helps narrow things down because I could just show you the same things that I showed you before and maybe add to that. But
somebody posted that.
Oh,
Wait,
yeah.
you can do the
So
one in the
what?
chat. Someone
Yeah,
posted,
what
and I'll
Tori
just post
posted in the
mine.
chat, I don't even know how to begin to define.
Yeah,
okay.
that's it, Tori. But I'm gonna post the one that I struggle with.
All right. All right. So to create a truth table.
Okay, let me write. I'm gonna make it as we go along.
It's mostly remembering the dadgum symbols.
Well, that's it. That's why I had mentioned that this little thing here is the key to that. Let me show you again. I got that little part that I took out of my notes, and there's also one in that textbook. Let's see. This is the heart of it right here. Because this is a breakdown of all those rules. The squiggle is negation. That just means the opposite.
Mm-hmm.
The little thing, it looks like, I think they call it a hat. It's over the 6. That's the and symbol, the conjunction symbol. The V is the counterpart to the union. That's the disjunction. It means or. The if then, the arrow only goes left to right. That's the conditional. That's the one that's dependent upon order. And then the biconditional. So this one is basically P, biconditional, not, all that in there, which is not Q or R. So let me just go ahead and draw a little thing. This is the hardest part.
So, okay.
Is
So
drawing
looking at this one,
out this part.
the P would have, so biconditional, it would have to be true and true on both sides.
Okay, but that's once we get all the other stuff done. Remember,
All the
the
elements,
goal is
yeah.
always to start with the most complicated and work inside out, generally left to right.
Okay.
So once we get all of this here, once we get all of this, boil down to one column, we can put it together with P.
So
What was
Alicia,
that?
I think what she was asking, so basically they're only true when both of the values match.
Match, yeah. That's
Like,
that's the bioconditional. And the
yeah.
Right there.
the if then, or the arrow that's just to the right, that one, that's the one that's dependent by order. So if
true
false is in
false
the
is the only
second place,
false one.
then it's false. Is that right?
That's right.
It's only if it's
Okay.
true, then true in the front, false in the back.
False in the back, then it's false. Okay.
Yeah.
Okay, so let's see if we can go ahead. So this part is the same as set up always. It's just going to be, oh, this has got 8. Okay, so we got P. Because you got 3 statements. So by that same formula from chapter 2, the 2 to the nth power. So we got 3 statements, 2 to the third is 8. Let's see if I can squeeze it in here. I initially thought it was just a 2 statements. So true. So when you always on the first column, it's half and half. So if it were just 4 rows with 2 statements, you know, two trues, 2 falses. So 4 trues, 4 falses. All right. The middle one is just going to be now 2 trues, 2 falses all the way down. If you do this, it gives you all of them kind of automatically, because all of these rows need to be different. Two more truths and 2 more falses. So see that? True, true, false, false, true, true, false, false. That's an F. Well, let me make that a little bit better, F. All right. So then this one is just true, false all the way down. And that would happen with the last column for any of them. We're only doing 2 and 3. So, but in theory, if you were doing 4, it would be 16. And we would do the exact same pattern.
Because there's a negation of the Q on the right, do we have to write that row of the negation?
Okay. So yeah, I'm going to start with this part right here. Inside. Okay. So I need to have, like you said, I need to have the not Q. Exactly. All right. So the not Q is just going to be this column flipped. In other words, opposite. That's what the negation is. All right. And I'm going to bring that back up. See the negation? There's really only 2 cases. If your P statement is, or if your original statement is true, the negation is false. If the original statement is false, the negation is true. So then what we're going to do is just go all the way down here. Oops, I'm sorry, the middle one. So it's false, false, true, true now. all the way down. All right. So now we got to hook that up with the R. So we're looking at these two columns, and we're going to put here the not Q. That's the not Q. And it's or R. Now, the main thing we need to know is in that column, we're using the or rule on these two here, on this one and that. I could just put the or there because that's what I want to key in on. I'm using the or. And remember, the or is true when either P or Q or both are true. And it's only false when both are false. So I'm just going to go down the line here, and I'm looking at these two. So I got one true, so it's true. This one's got two falses, so that's false. Any number of trues makes it true. So these two are true. Here's another false one because it's two falses. That one's true. And then that one's true. 1, 2, 3, 4, 5, 6, 7, 8. Now, we're going to take the negation of the whole thing.
Wait, so the first one, why wouldn't that be false? Like the first two are and not Q.
You mean right here?
So you compare the T and the F, yeah. Is it because of the not? I don't.
See how the or, we're using or here? That's the or.
Oh, okay. I was doing and. Shoot. Okay.
Yeah, that's what I'm saying is you got to get in your head the one that you're using because there's 5 different ones. They're not interchangeable. So that's what we got to do. And that's the most common thing is just to use the one. I'll do it too. You'll see me. But that's the purpose of going back, double checking. Okay. Now, what I'm going to do is, like I said, I'm always preferably working on 2 columns. And if I can get the 2 columns right next to one another, that makes it better just because I don't have to read over things. So what I'm going to do is I'm going to put here the P again, since that's right there. All right. So which is going to be true, true. All I'm doing is just transplanting it over here. So it's closer to me. All right.
So quick question. The one that you just finished working, the not Q or R, we don't have to make a row next to that one, figuring
I'm
out
going
what
to
the
make it
negation
now.
is.
The
Okay.
reason why I put the P there is just so that the 2 would be right next to one another. Now I'm going to do that one. It's not,
Okay.
it's just a matter of preference. Like I said, I like to always be looking at the last 2 columns if I can manage it. Because when you have to read
Okay.
over a column, you know, it plays tricks on my mind. So that's why I'm doing that. So I'm showing you these kind of things that can be helpful. Now watch. Now I'm going to do what you're asking. 1, 2, 3,
Okay.
4, 5, 6, 7, 8. Now I'm going to take the opposite of this one. So this one, I'm just going to type it up there. Since I'm okay, so that's that one right there. So that's just the opposite of this one. So that's going to be true, false, true, true, true. So everything's going to be flipped on its head. So false, true, false, false. Like I said, it takes some concentration. You got to pay attention to it, because if you kind of get distracted, you might think about the wrong one. You might look at the wrong rows. I'm sorry, the wrong columns. So that's my strategy when I put the two together like that. So let's see, false, true, false, 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 true, false, false. Now the ones that I'm looking at, or for the last one, I'm looking at those two columns.
It makes sense.
Yeah, I mean, like I said, if you're good at blocking things out, you could have immediately jumped and just done the not and then read over to the P, or you could have put the P next to it on the left. Well, I got it on the left, or you could put it on the right. It doesn't matter. It's just as long as you're looking at the right two rows. Now, we're using the biconditional here. So I'm using the biconditional on these two columns. So now I'm using this one. Okay. And that's the one where they have to match. If they match, it's true. Another way of looking at it is equivalence. Okay, so if they're the same, so these two are different, so false. These two are the same. Those are different. Those are different. Those are the same. Different. Same. And same. And now we're done. 1, 2, 3, 4, 5, 6, 7, 8. There is the truth table for that whole statement right there.
So it's not a contradiction because all of them aren't false.
Right. This is a neither.
Okay.
If it was all T's, we would call it a tautology. For all F's, it's a contradiction.
I think I was just breaking the problems down wrong. It's just so tedious.
Well, yeah, you can see. I mean, it took me 15 minutes to do that.
In the
Now, like I said, it's not. What's that?
right. In the exercise, it also said something about an implication, which I didn't know what that was.
An implication is just essentially means it's got an arrow in it. In other words, it's an argument. Let's see.
Okay.
It's not that one is not. Did you see that anywhere else besides my notes?
No, I saw it in the Newton.
Yeah.
Yeah.
Some people use it and use it with the definition of an argument, but an implication is just a conditional, wherever it's at. I mean, it's good to know, like in case you see the term.
Yeah.
But it's just a conditional statement that's a tautology. And that's what an argument is. An argument, by definition, is the conditional statement because you write it in that conditional form. And so an implication. So an argument that's a tautology is valid, and you can also call it an implication. All right. Any questions about this?
Yeah, I just kept on getting that one wrong because I was confused with the double negations.
Yeah, the double negation. Like I said, yes, you just gotta realize there's, these 5 different. They're all different. The only one that's the same is the top one, but that's just I don't see it's a coincidence, but see, all of these are true. But after that, see, like for this one, all of them are true. All of the 4. Okay. But all after that, they're all different. So you cannot interchange them. You use the one, and like I said, start with the most complicated, work your way out. All right. So anybody got another one? Anybody got another one that we can look at?
I got another one, but I'm just not sure if it's going to be on the review. So it's like they give you what P is, what Q is, find the value of this statement and this statement. Like
So was that, it wasn't in the review?
it was,
Or you
it
don't
wasn't
know
in the
yet?
review. It's in the Newton exercises. I don't know yet.
All right. Can you type it out?
Yeah.
If it's what I'm thinking that you got, I did see it is in. Okay. All right. So they just want to know the value of this statement if we set P false, Q false. So is that 3 different ones?
It's 2 different statements, right?
Oh, the first one was the one that you gave me before. Okay.
Yeah.
Okay. I got you. It didn't take it away.
I
All
just
right.
kept getting this one wrong as well. So they give you a multiple choice answer of saying
Yeah.
the first statement is true and then the second statement is false.
All
And you
right.
have to pick, yeah.
I'll show you how to handle it. The easiest way. You could create a truth table for it, but you don't need to. All right. So
Yeah, I kept on doing just like replacing the values with the falses, but
yeah,
it kept on getting
that
wrong.
okay, let's see. I'm sorry, both are false, right?
Yeah.
Okay. So what I'm going to do is I'm just going to take that, and like you said, I'm just going to replace things with it. So then what I'm going to do is just put a false there. All right. So this is just the conditional statement. If F, then F is a true one because that's the one on the bottom. See? False, false. So if false, then false is false. So then it's going to be false. Do it inside the parentheses first. False or false is false because the or is only false when both are false. See? So that's that one. Does that make sense? You work in the parentheses first, just like when you do in the truth table.
Yeah, that's what I got.
All right, let's get that other one. So I'm going to do the same thing with this one. Same values. So it's going to be false. So all I did was just replace the P's and Q's with what they had told us there. P is false, Q is false. So then I'm going to work and evaluate inside out. So again, this is that same one inside of there. That's false. We don't need those parentheses anymore because we evaluated the 2 into 1. All right. So then this is false. Arrow false, which is true.
And that's where
Okay.
I got it wrong. Yeah.
Did you get the last step wrong?
Yep, I kept on
Okay.
getting false. Yeah.
Yeah, because of the fact that you're probably thinking about because of the fact that the or and the and are both false there. So those are the ones that stick out in your head. So yeah, you got to make sure you're looking at the right one because they're all 4 different. All right. So anybody got anything else?
Well, I'm definitely going to watch a couple of explainer videos.
Yeah.
That way I can catch up and not take away from the other students.
Well, like I said, I mean, I don't mind going over anything because I got plenty of time here. We still got 45 minutes. So
I mean, I was going to catch you after
that
120 when you stay behind and, you know, get a rundown, because put it this way, and what you're doing, I mean, once I remember the symbols and what they mean, I'm pretty sure I'll get it. But what I'm looking at on the screen is like Chinese to me.
Well, the key is right here. The key is right here. This is the key to it.
Right. That's so that little box, you know, is the key, but I need to know how to implement it. That's my problem. It's not that I'm not paying attention. but
Right.
I was just very bad at math. I dropped out, got a GED, and math was my never.
Well, you can almost think this is really not math. This, like I said, I first took this in a philosophy class. The reason why we go over it is just because logic is the basis for all languages, including math, English, any language. So that's why, you know, it's included in a math course. Like I said, there's nothing really to add like you would normally expect in math. We get adding and subtracting and multiplying and taking square roots. In this chapter, it's just all about logic. And like I said, it does flow from the set theory.
Will we have the key, or do we have to remember each what's
this
on that?
Yeah, I mean, and that's what I said is that's why I offered the advice is use this while you're doing your stuff, and then if you do it enough, will be able to get them into your head.
I remember two
like
of them. I'm just trying to catch up with the
like
other
I said,
one, you know.
But I'm not very good at remembering stuff, at least not verbatim. That's why I use these things down here.
Well, I was in a car accident, a severe car accident, and my memory's not the best either. So
that's why I'm the same way. I can remember stuff, but learning new stuff is pretty difficult for me. So that's why I don't try to remember stuff anymore. I remember some concepts of things. So those things that I've circled there in pink, that's what I remember. Now, because we can say that the conjunction, the and, is only true when both P and Q are true. Now, why is that true, you think? Because it relates back to the concept of intersection. Unless you're in both, unless both are true, it's false. Both of the statements have true in order for the conjunction to be true. The disjunction is kind of a sloppy opposite. So instead of being three falses, like for the conjunction, there's three trues for the disjunction. Because when you're dealing with the disjunction, it's the or, the union, as long as you're in one or the other, or one or the other are true. It's one or the other true, it's true. The only time it's false is when both are false. So like my way of handling this is going through and just marking all the ones that are false for the disjunction, and then I can come back and just put in all the rest truths. The biconditional is just the one where they're the same. Another way of looking at it is equality. If they're the same truth value, both truths or both falses, then the biconditional is true. It's when they're mismatched and not the same that it's false. The conditional statement is the only one that's order dependent. And that's order dependent because of the fact that the only one that's false is this rascal right here. See that? Any other order, true is true, false is true, false is true. The only time it is false is when you have order, true, false. And that's one reason too why I try to always work with two columns, the last two columns, and then I'll rewrite. I don't really need to do it over here. It was just a matter of convenience so that I'm not having to read over columns. But you got to get the order right for the conditional. So that's why I put the two right next to one another in order. See, I put them in the same order here. It wasn't a conditional.
So at the end of math, at the end of 120, would you have a couple minutes to step by step go through this with me, if you don't mind?
Well, when you're saying go through,
well,
I mean,
all right, keeping this little chart here up, and then
yeah, well, that's what I've been bringing it up. Well, I'm going to go ahead and do that right now. How about right now?
Let's go. Let's do it.
I mean, I don't have plenty of time. I just need to kind of know, you know,
because I don't know about
idea.
all y'all, all the other students, but this is gibberish to me, and I just got to remember the symbol.
Yeah, I mean, the only thing is, is knowing this table right there. If you know that, that's most everything, 75% right there. All right,
Let's
so
try another one.
Let's see if we can find one to do. I think over here in my notes, I had one that I had an extra one, like for an argument. If not, I can go over to the book and get it.
Yeah, like how you make that chart, and then I'm pretty sure I saw somewhere you got to translate that into words. That's just
right. Well, that's what we're going to do here. Okay, here's our argument. All right. So this is basically most everything in the course. If we can find out if is this a valid argument. Now, just looking at it, you're not going to be able to do that and tell by just looking at it. So what we got to do is we got to take and translate things to symbols. So let's see. How many statements are there? Let's see. We got run the marathon, run 30 miles by Christmas. So there's no other statements. So let's go ahead and define those. There's just two statements. All right, so there's our statement. So now what we're going to do over here on the side, I'm going to write these symbolically. So I got an if and only if in the middle there. So this is going to be P. Okay. Do you see that? Let's make sure everybody's up on that. Do you see how I translated that symbolically?
And just for clarification, the greater and lesser than and the two dots is what?
That's the conditional, the biconditional.
Biconditional. Okay.
And it's the if you see if and only if too. That helps as well.
Thank you.
So just to make it look more like the symbol. It's just on the keyboard. They don't have that symbol. You got to make it. Okay. Now, what about the next one? I can run 30 miles by Christmas, so that's Q. Or what? Not P, right? I can run 30 miles by Christmas, or I will not run the marathon. The V is the or. The little squiggly line is the negation for the P, the not run the marathon. But one of the things that I've learned as a teacher, you don't ever have to be concerned about asking about stuff, no matter how far behind you are, because there's other people in the same boat. You know, they're just afraid to say something. So don't.
I mean,
Don't
I was
feel
nervous
bad.
in the beginning, as everybody knows. I didn't say anything, but when you don't know something, you got to ask.
Exactly. All right. Now that line means that everything above is a premise. All right. The conclusion is what follows down here. That just means, therefore, that's the same thing as the conditional statement. So now, what do we got? If I ran the marathon, so that's P arrows always just goes one way, then Q. Did I get that right? If I run the marathon, if P, then I'm able to run 30 miles by Christmas, then Q. Okay? Make sure you got it up to that point. Close the next step.
I got that
now.
point.
Okay, good. Like I said, if you can get this, you got 75% of everything else. Because there's some things in there about, the equivalent statements and the essentially the equivalent statements and the what do you call it? The De Morgan's law kind of things. That's the other 25%. But we'll concentrate on this because this is the hard. If you got this, the other stuff is not so bad. All right. So now we're going to write the symbolic argument, which is what I just created. Okay. So that's going to be P so all of the premises, in this case, there's only two of them, they're separated with an and, the conjunction. And there's the second premise. Close that off. Oh, the bracket. Not the curly bracket. It's not a set. All right. So that's everything above the line. See that? That's this part right up here. Now, that dot thing, that's the translation to the conditional statement. An argument always translates as a conditional statement. And this one is got two in it. So there we've got the conditional statement. All right, so this is only 4 rows, so yeah, just P and Q. So we should be able to squeeze it in here. So I'm just going to go ahead and create that little table. I need to get one of these that I can just import, like a template. So I don't have to rewrite this every time. But rewriting it every time shows us that it's going to be the same every time. So this part's always going to be the same because you want to make sure so half and half. First column is always half and half, no matter how many rows you got. In this case, it's just 4 rows because and let me just put that here. There are 4 rows because there are 2 statements. And it's just a matter of, it's that same formula from chapter 2, the 2 to the end. So there's 2 statements. So 2 to the second power is 4.
I was wondering where you got that from. Yeah, I get it now. 2 to the second power.
So 4. So if there's 3, like if there was an R, then you're going to have double 8 because every time you add a statement, it doubles. All right. So then on this one right here, it's just true, false. The last column is always true, false all the way down. All right. So this one is going to be, so we're just going to go left to right and do each one of these. So this right here. Is that one on the inside? We're doing the insides. All right. And that one is just going to be verbatim because these things have not been, we don't have any other operations that have been done. So this is just verbatim. If they're the same, it's true. So this is true, false. They got a match for the biconditional. All right. Now that's that one done. So let's try this one. We got to have a not P. So the not P is just the opposite of P. So instead of true, true, false, false, it's false, false, true, true. All right. And then we could write the Q again, but I'm going to work without a rope here, and I'm just going to skip over that third column and just read the Q and the not P. So this is going to be the Q. We don't have to worry about order here because it's the or, it's not the conditional. So remember, let's bring this up. So what we did the first time here for the middle one, it's just this one verbatim, because as long as they match, it's true. If they're mismatched, it's false. For the or, we're looking at it being true. As long as there's one true in there, so true, false, true, true. This is the one that's false. Q and not P are both false. Here's one true. There's 2 trues. There's one true. So as long as there's one true, it's true. The only one that's false is that bottom. It's the bottom row. Now these are in a different order now because we've already done some operations. We're using ones that have been already congealed into one column, like the not P. So you got to pay attention to that. It's not just copying the order there like we did on the first one. All right. So that's that one right there. All right. Now what I'm going to just put right here is just the and. I'll tell you what, type that thing out. Okay. I'm going to use the and rule. On this one and that one. So yeah, I've made this one into that one. I've made this one into that one. I'm still working inside the parentheses, so I'm putting both of my premises together with an and. Okay. So, and is the most restrictive one because it's only true if you got two truths, otherwise it's false. So true, true is true. False, false is false. False, true is true. Oops, I'm sorry, false, because it's the and. And then the bottom one is true. All right, so this right here is the whole left-hand side. All right, that's the whole left-hand side. See, that's this part right there. The whole thing on the left side over here. So now we got to do this one here. And then once we got that, we put them together with that one final arrow. The good thing about this next one, it's just the verbatim one, because we're using the original P and Q. Nothing else is done to them. So see that? We're looking at the one right here. So it's only false when we got order true false. So let's see if there's any of those in there. So this right here. So now that's just true, false. True, true. So see, we're looking at these over here, the two, the P and the Q. So true, true is true. There's the false one. True, false is false. All of the other two, false, true is true, and false, false is true. All right, now last step. All right. Now we're working with these last two. We're working with this one, and we're working with this one, and we're using the conditional rule on these two here. Because this right here, that little and, represents everything that's on the left-hand side. The P, if P then Q, of course, is the right-hand side. So once we got both of them, we put them together with the arrow, the conditional. So this is going to be true, 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 and true. Again, we're using now the conditional rule right here. We did not have the one that causes trouble, the true, false, in that order. See, we only had true, true, false, false, and false, true. This one didn't exist in there. So therefore, what can we say about this argument?
It's
Since this tautology, it is valid. So being able to take and translate an argument into symbols and then write it as a statement and create the truth table for it is 75%. of the content. And we'll have time in the next class to go back into this if we still want to look at it, because like I said, it's a complicated process though. All right, all right, so let's see. I might break out the textbook for the 020 textbook and get a couple of problems, because what I want to look at now is the other 25%, I guess you could say, the De Morgan's laws and equivalences and such. Okay, so let's see. I'm pretty much going over everything in my notes that had to do the problems in the notes. So I want to find a fresh problem or two to carry us. All right. Yeah, I mean, that's the symbols. But like I said, you don't necessarily have to remember what the symbols, like I said, those truth tables, but you got to realize that it's the same thing as back in set theory, the and, the or, the if then, and if and only if. Those things existed over there. They were just called by something else. So if you can kind of bridge that gap, because I know you did pretty well on chapter 2, Matthew. If you just bridge that gap.
Yeah, I got a 75. At least it's a C plus, but you know, I'm getting there.
All right. So let's see. All right. We talked about the tautology and the contradiction. The tautology is all truths. The contradiction is all F's. And then if it's got one to spoil, it's like, for example, this right here is just showing you about two statements that are logically equivalent. Like this is one of those that's kind of given to you because we want to be able to use it with De Morgan's law. But this is the basic conditional statement, verbatim from over there in chapter, in that little thing that we looked at. And they show us that not P or Q is logically equivalent. It's the same order. Now, the reason why they're doing that is because we don't know how to really negate a conditional statement, but if we write it as a disjunction, we can take it and do the negation using De Morgan's laws. All right. Let's see if we can find something here. I think we did that one last time. We did the first two up here, so let's do the second two. So we want to write the negations of the following statements using De Morgan's laws. And just remember, that's De Morgan's laws. These are the same things that we carried over from chapter 2. The negation of the disjunction is logically equivalent to the conjunction of the individual negations. And then the negation of the conjunction is equivalent to the disjunction of the individual negations. And I've tried to explain this because this is kind of helps. But what happens when you pass that negation sign along, you know, like in regular mathematics, you just pass it on to the two signs. Well, the same thing's kind of happening here. You pass the negation on to each one, and then the or changes to an and. Same thing here. And changes to an or. So let's look at these. We did those yesterday. All right. So here's what we want to do. We want to do the negation of that. So first of all, I'm going to write it as a statement. I mean, a symbolic statement. So let's say P, it is silly. Q, I have sense of humor. And I write them in the positive because I'm going to negate them when I write it out. So therefore, we've got, for this one, it's P, I'm sorry, not P, because that's not silly or not, or no sense of humor. Okay. Now, here's what we're going to do. We're going to use De Morgan's law, because Morgan's law to find the negation. So we're going to take that thing and we're going to write it in the same thing in parentheses and then put the negation on the outside. And that would give us the negation. All right. So then what happens is when we negate something, we do the opposite of it. So it's the negation of a negated P is just P. The or changes to an and then the negation of a not P is Q. So therefore, this is going to be, it is silly and I have a sense of humor. All right, there's our negation. So the negation of it is not silly or I have no sense of humor is, it is silly and I have a sense of humor. Let's see if we can squeeze the other one in here. The movie is a comedy or a thriller, and it is awesome. Oh, wait a second. This has got 3 statements. Doesn't.
So would the last one be an R or?
Yeah, I guess that's what it is. Let me cheat here a bit because I'm starting to run into time. Okay, yeah, it is. I just wanted to double check. All right. So Q is, what was it? It is a thriller. This is kind of an advanced one. And then R. The movie is awesome. All right. So then the way that gets written out is right over here. P or Q. Notice that they have a comma there. That's where we break it apart with that comma, okay? This is all what the one statement. It's all an or statement. And over here, this is the R. All right, so we're going to negate this. So let's put that, the negation. So that's what we're negating. So let's say we're going to do it in two parts here. So we're negating. We're going to do a negation of a negation. So this one gets negated. This gets turned around and not R. All right. And then the last part, then we're going to apply De Morgan's again. Not P and Q. And not Q. And then that or becomes an and. And it's just going to be regular OR. So that will be writing it in words. The movie is not a comedy and not a thriller. And it is awesome. All right, so that's pretty much, I guess, as determining negations. You can also use the other two. You can also use the De Morgan's law to find equivalence as well. We can talk a little bit more about that in the next hour. I think we're about out of time to work on another problem. Anybody got any specific questions? If you want to stick around, otherwise go, and I'll see you back at 12:30, okay?
Hey, thank you.
Bring good questions. Keep me busy. I mean, I can always bring up stuff. I just rather hear from you guys.